Welcome back to our system design series. Today we are going to talk about a concept that plays a crucial role in making database queries fast and efficient, which is database indexes. If you are ever wondered how databases can quickly find the information you need, the answer often lies in indexes. So, what exactly are database indexes? In simple terms, an index is a super efficient lookup table that allows a database to find data much faster. Imagine a database table like a massive book with thousands or even millions of pages. Without an index, finding a specific piece of information would mean flipping through every single page until you find what you are looking for. An extremely slow process. A database index act like the table of context or an index of the back of the book, for example, pointing you directly to the exact location um, of um, of the desired data. So let's take an example to truly understand that. So let's say that we have a big table right now. We have a big table with all of these rows. So if we're trying to search for a specific thing, our data have to read everything, which will be super slow process. But if we have indexes, key and indexes, and these indexes basically in this index or like this pointer points to a specific row in the table, finding what we need is way more faster. So indexes are created on one or more columns on a table that store the values of those columns along with pointers or indexes to the corresponding rows. This means that instead of scanning every row in a table, the database can use the index to quickly find the relevant rows. Think of it like a map that helps the data set database zero in one in one exactly where in on exactly where it looks. Sorry for that. So let's try to think in a deep example. So let's imagine that we have a table of customers with millions of records, and you need to make a look up a customer by their email address, for example. Without an index, this database would need to perform a full table scan, checking every row to find the matching email. A process that can be extremely slow. By creating an index on the email column, the database can use that index to find the matching row almost instantly because we don't have to read every single row. We are looking only at the index and we have the pointer of it. So it makes it way more easy. There are several types of database indexes and each one has its own specific use cases. The first one, which is the B tree indexes. Let's me. These are the most common type of indexes used in relational databases. B-tree indexes are highly efficient for searching, inserting, and deleting operations. They allow the database to quickly narrow down the range of values and find the exact match, which is ideal for most queries involving equality or range conditions. The second thing we will talk about will be the hash indexes. So, hash indexes are used for situations where you need fast equality lookups, such as finding a record by its exact value. Hash indexes are not ideal for range queries, but they are extremely fast when you need to find a specific value. Number three, we have full duplex, full text, sorry, full text index. So These indexes are used to improve the performance of text searches. For example, if you're building a search engine for a blog or an e-commerce site, a full text index can help you efficiently search for specific words or phrases within large amount of texts. So, while indexes are incredibly useful for speeding up read operations, they also come with some trade-offs. Indexes take up additional storage space, and every time you insert, update, or delete data, the indexes need to be updated as well. This means that while indexes can greatly improve the speed of read operations, they can add overhead to write operations. It's important to strike the right balance between having enough indexes to optimize queries and not having so many that they impact the performance of data modifications. A good practice to analyze your query pattern and create indexes on columns that are frequently used is where there is okay, there is where clauses. Also, there are join conditions or as part of order by as well. Clauses. For example, if you often search for customer by their last name, it makes sense to create an index on the last name column to speed up those searches. However, be careful of over indexing, like having too many indexes can slow down your database because each insert or update require the database to adjust all relevant indexes. It's also important to remember that indexes are most effective when the indexed column has a lot of unique values. Indexing a column with many repeated values like a boolean flag may not provide significant performance benefits. So that's it for this video, and I hope you like my content. If you like my content, subscribe and hit the notification bell so you'll never miss a video, and see you in the future.